In this video, we're going to create our project as well as set up the basics and create movement for our player. So the first thing you want to do is open up the Unity Hub and start a new project. In this project, we're going to use the universal 2D template. I'm just going to name my project Boulder Avoider, but you can of course name your project whatever you want. Click create project. So after an incredibly long wait, the Unity editor should open up. So the first thing we're going to do is add our player to the game. Here you have your scene view, you have your game view. This is what you'll see in game. I'm actually just going to take this tab and drag it down here. I like to see my scene and game view simultaneously. Now that we can see our game and our scene view at the same time, I'll just go ahead and right click here in the hierarchy, go to 2D object, sprites, then I will add a square. You can add whichever shape you want. I'll just use a square and I will call it player. I will move it a bit down because we'd like our player to be somewhere around here. And just to make it easier to see, I'll just make it red. We will be adding an actual sprite later at some point, but right now we just need to get the movement working. So to get the movement working, we will be using the input system. So I will go back into project. I will create two folders we're going to need. You can either right click, create, and then folder, or you can hold down Control Shift and press N. And I will create two folders. I will call one folder scripts and the other folder I will call input. I will go into my input folder. I will right click, create. Down to the bottom, we can create a new input actions. I will call this layer controls. And then here in the inspector, you can see we can tick this called generate C# class and hit apply. This will create a new C# script called player controls. As you can see, this can look a bit confusing, but we won't be editing in this script. This is just how the new input system works under the hood. So now let's edit our input actions. We will go to this player controls, double click it to open it up. And you can see we have these different tabs in the input actions editor. I will go through them one by one as we create them. On the left, you have your action maps. We can hit this plus sign to create a new action map, and I will call this movement. Think of an action map as a specific control scheme for a specific scenario. So let's say that in our game we could enter and drive a vehicle. Well, we could call this vehicle controls. Not sure if I spelled vehicle correct there, but you get the point. So we can have one for movement, walking, running, whatever, and we can have one for vehicle controls. We can add one for combat as well, etc. Let's just delete this vehicle controls as we won't be needing it right now. Then here we have our actions. But first, before we create a new action, we will need to go to the action properties here on the right, and we're going to change the action type from button to pass through. And then the control type, we will be using a vector 2, as we will be moving on two different axes, X and Y. And then here, if you expand the new action, there's this binding that comes as default. We can delete this before we go any further. Right click new action and rename it. I will rename mine to move. And now we can create our movement system. Again, naming does not matter at all. You can call it whatever you want. This just makes it clearer for me and hopefully you as a viewer. So I will click this plus sign and I will add what is called a up, down, left, right composite. You can see it adds this 2D vector. We can expand this as well. And here you have your bindings for up, down, left, right. As you can see, there's no bindings for any of these as of now, but we can click these bindings. We can go out here on the right to binding properties, click path. You can set this either here, or the easier way might just be to click this listen button. And then I will click, as we're on the up binding, I will click W on my keyboard, and this will register that I pressed the W key. So a bit easier way to set these. I'll set S for down. I'll use A for left, and I will use D for right. Before we exit our input actions editor, you can see this asterisk here. Just means we haven't saved it. So I will go ahead and save my asset. So now that that's saved and compiled, let's exit out the input actions editor. And if you mark the script again, you can see here in the inspector, we scroll down a bit and you can see this added some input actions. It's called player controls, movement, and move, just as we named ours. It uses a 2D vector and it uses the bindings up, down, left, and right. So again, we're not going to go into this script at all, just to show you this how it works under the hood, and it has registered what we've added to our input actions map. We're going to go back into the assets folder and now into our scripts folder, and we're going to create a new mono behavior script called player controller, not to confuse with our player controls input actions map. Now that is done compiling, we will just, before we go into the script, go to our player. We will add a few components. We can start by dragging our player controller script over here to the inspector. Now that's added to our player. And we will also be adding a rigid body. Remember to add the rigid body 2D. We will not be using gravity for our player, so we will set the gravity scale to 0. And to make sure collision works properly, we're going to set this from discrete to continuous. Now we can open up our player controller script. So when we first open up our Visual Studio or whatever code editor you are using for this is what you'll see. So we have two methods here. We have the start method and the update method. When you create a new mono behavior script in Unity, this comes by default. You don't have to use these, but a lot of the times you will be using these. As you can read from the comments, start is called once before the first execution of update after the mono behavior is created. So when you start the game, whatever happens inside this block of code will execute once. And then you have your update loop, which is called once per frame. So if your game is running at 60 frames per second, whatever code is in this block will be executed 60 times per second. So one time per frame. I will be deleting these comments for now, as I won't be needing the comments and it will make it more readable for you, hopefully as a viewer. I will delete the start method as I won't be needing that as well. What do we need first? We will need a move speed of some sort to determine how fast our player should move. For that, I will create a private float and call it move speed. And I will set this to 1f. And actually, I will also add one more thing. Inside square brackets, before I create my variable, I will enter serialized field in square brackets. Serialized field is built into Unity as well. And this ensures that even though this is private and not public, this variable will show up in the editor and we can edit it on the go. I will just show you here in the Unity editor. We are at player controller, our script, and we can actually edit our move speed out here, even though it is private. If you're wondering why I'm keeping this variable private and not public, protected, or anything else as an access modifier, I will upload a video where I explain when to use serialized field, when to use private, when to use public, when to use protected, and the best practices, like where to keep your fields, where to keep your methods, where to keep your properties, so on. What we need to access now is the input action we created before. So our player controls. We can instantiate this from here by typing private player controls, which is what we called it. I will call mine player controls in this script as well. Now we will need some sort of direction for our player to move in. We will create a private vector2. As you can see, when I type vector, that's vector2 and that's vector3 and vector4. Vector2 is used when you use 2D axis, so X and Y. But if I were to create a 3D game, I would be using the vector3 as this has the Z axis as well. But for this, we'll use a vector2 and I will call it movement. If you remember before, we also added a rigid body 2D. We will be needing this in our script as well. We added that to our player. So I will be creating a rigid body 2D. I will just call it rigid body. And for now, these are all the fields that we will need for this script. I will use another built-in Unity method called awake. Awake is called right before start. So also when the game starts up, this is called once. This is where we can do stuff like initialize our fields and get our components. So we will start by initializing our fields. We will use our player controls and we will set this to a new instance of player controls. So now we can access the input action map. And here comes a little show and tell and then a mini challenge for you. If in our game you look at our player, we have different components. We have the transform, the sprite renderer, our script, our rigid body. Sometimes you would use these components in our scripts and we will need to get these components. So for instance, let's say I wanted to get a hold of this sprite renderer component in our script. I would create a field for it, sprite renderer. Let's just call it SR for now. And in awake, I would be getting that component by typing SR, so the name of our variable, equal to get component. And then inside angle brackets, I would add the type of component we wanted to get, in our case, a sprite renderer, and then finish off with open close parentheses and a semicolon. So now I can use this, for instance, down in the update in our other methods. I can use sprite renderer and then all the methods that's attached to our sprite renderer. We won't be needing our sprite renderer right now, so I will be deleting this once again, but now a mini challenge for you. We will need our rigid body 2D component. So try and get that component. So the challenge for you is try to get that component in awake. I will give you a quick sec to pause the video so you can try this for yourself. And then afterwards, you can follow my solution. So to do this, we need to access our rigid body. We've already created this up here. So we will access our rigid body and we will set this to get component rigid body. We need to remember it's rigid body 2D and not just rigid body. And then open close parentheses and semicolon. So now we have the rigid body, and this is all we need for our awake method. Now, before the player controls will actually work in our game, we need to enable it. What do I mean when I'm saying enable? If you go to Unity editor, you can pick any object in our game scene. You can see here, we'll just take our player in this example. I can go to the inspector and I can untick this. Now it is invisible in the scene. It won't interact with anything. It is disabled. So now when I tick the box here, it's enabled. So enabled just means the object is active in the scene and can interact with the game. While disabling is the opposite. There's built-in methods in Unity for this. We will use the method on enable. And in here, you will just type player controls. So our variable dot enable. In our game, we won't be disabling the player, but it's still good practice that when you enable something, you should also have a case for disabling something. And another mini challenge for you, now try to add the method for disabling our player controls. Again, I'll give you a quick sec to pause the video so you can try this for yourself, and then I'll show you how to do it. For this, it's kind of similar to how we enable the object. We will just type private void on disable, and in here, you guessed it, we will type player controls dot disable. And now we'll use the next method in Unity, which is built in. We have the update. And this is a really good place, as this is called every frame, to register inputs. So for instance, if we press the WASD keys, that should be registered, and then we should move accordingly. And we need to register that input inside of update. But not to make update too long and too messy, we will actually keep it inside our own method and call it inside update instead. So we will be creating a new method, private void player input. And just to make sure we don't forget, we will just call it up here in update. We will be needing our movement direction. So this variable we created up here, private vector2 movement, and we will need to set this equal to something. This line can be a bit of a tongue twister, but I will write it and then I will go through it with you. We will need to set it equal to player controls dot movement dot move dot read value, and inside angular brackets we need the type. Which type are we reading from? We are reading from a vector2, then parentheses and semicolon. Now, why am I typing all of this? Where do I get this from? If you go back into the Unity editor, go to your input folder, and then inside this player controls input action map, we will open this. This is called player controls. We've called our input action player controls. We've created the action map called movement. Then we have the action move, which utilizes a 2D vector. And in our script, we have player controls, so the name of our input actions. We have movement, the name of our action map. Then we have move, the name of our action. And then we read the value of a vector2, so the 2D vector we are using. And just to show you this in action, if we type here debug.log, this is just to write out to the console. So if you want to check any variable and write it out to the console as you play the game, you can do that using debug.log. And we will write out our movement. We need to specify an axis. I will just use the x-axis. I will just drag my game tab up here so we can see the console simultaneously with the game view. When we start the game, this is constantly spitting out 0. This is our movement.x currently. If I press the D key on my keyboard, it will go to 1 because it's now positive on the x-axis, meaning that it's moving to the right. And if I press A, it will go back to -1. And if I press no keys, it will go back to 0. So -1 for negative. When I press A, moving to the left, D, moving to the right, no keys, it will stand still and have no x value inputted. So now that we know that our input is registering correctly, we can remove this debug.log as we won't be needing that anymore. And then we need to create a new method for actually moving our player. We will create a new private void called move, and we won't actually be calling this method in update. Usually it's best practice to use update to register player input, but when you're handling stuff like physics and movement, we will be handling this in another built-in method called fixed update. And here we will call our move method. So we have update and fixed update. Now to move the player, we will need to access the rigid body that we created earlier. So we will say rigid body, and it has a built-in method called move position. So it moves the rigid body to a position. And to do that, we will need to specify our current position and add our movement direction to it. So our current position is our rigid body dot position, and the direction we're moving in would be movement. And right now it will stand still because our movement speed is currently 0, but we can multiply this by our move speed, so the float we've set right at the start of the script. And then we will need to multiply this with time dot fixed delta time. You may be scratching your head right now saying, well, what is delta time? Delta time is to make the game frame rate independent. So even though you have a beefy PC that runs this game at 340 something FPS, it will still move accordingly to the time passed in game and not your frame rate. It will move the same speed no matter the frame rate. Just a quick performance tip. Here we take a vector 2 and we're multiplying it by 2 different floats. It can be a bit better for readability, but also for performance to multiply the 2 floats together first. So we will just put this move speed times time.fixed delta time inside its own parentheses. So we only have to multiply the vector 2 by 1 float. Save the script, and you should be able to move using WASD keys. It's a bit slow for my taste right now, so I'll go to my player object. This is why we serialize the field, so I can edit this on the go. I will set it to 5, try this out instead. Yeah, it feels a bit better. You can play around with it a bit, make it a bit faster, make it a bit slower. This is why we serialize the field, so you can edit this on the go. Just remember, if I try to control this now, as it says, you must exit play mode to save the scene. So if we stop the scene, this will go back to 1. Maybe I don't remember the value I actually set when playing the game. I can fix this by just going to the 3 dots here for our component, and I can go to copy component. And when I exit the game and this is set back to the original move speed, I can click the 3 dots again and then paste component values. So now this is set to the value I set while in play mode. Just remember, this won't change what you set in the script. So even though this actually won't change anything, just best practice to keep the same value in your script as in your editor. So now we have a moving player. I hope this video was helpful, and in the next video, we will be adding falling boulders, which our player has to avoid. If you found this video helpful, please consider adding a like and a comment, as this will help me out massively, and also subscribe for more content. Thank you for watching.